Hey guys, okay, today I'm gonna share with you how I solved the Advent of Code year 2020 day 19 puzzle with Elixir. So let's get started. First off, let's look at the question. So there's a bunch of backstory, but I guess let's look at the example. So from the example, we see that this seems to be some sort of a tree, and then there's some sort of recursion going on. And then at the end of the recursion, we need to get some permutations of messages. All right. So looking at the tree, there is a root node, node 0. And this node 0 has 3 nodes, 4, 1, 5. So node 4 is A. So A is the end node. So as long as it's either A or B, they are the end node. You only have two possibilities. Right. So number 5, node 5 is B. And then node 1, it actually has 2, 3, or 3, 2. So it branches off into 2 branches. Right. So node 2 is double A or double B. Node 3 is AB or BA. Okay. So it seems like there's a pattern here, right? There is an OR operation, which is symbolized by this vertical line. There is also another operation, which we would just call it AND operation. So you can think of it as AND operator. So the AND operator is all the space here. So you can think of it as 4 and 1 and 5, right? 2 and 3, right? So this is one group. All right. So once you get the permutation, seems like it will give you a set of messages as well, and then you have to match them and give it a count, and then that count will be your answer, right? So, but first off, we need to see how to recurse this tree. So let's draw it out first to understand what exactly is happening. So let me get my pen. So the tricky part, if you look at the tree, right, is actually 1. So let's try to analyze 1. So you have 1 here, and then 1 will branch off into 2, 3, or 3, 2. And in 2, 3, 2 will branch off into 4, 4, or 5, 5. 3 will branch off into 4, 5, or 5, 4. Let's resolve for this part first, left-hand side of the tree. So 4, 4, 5, 4, 4, or 5, 5 basically means it's AA or BB. And then 4, 5 is AB, 5, 4 is BA. So this part is N, this part is OR, right? So how do you go back? So to go back to, from the bottom node, back to node 2, 3, basically you need to do this. So it's AA or BB and AB or BA. How do you solve this, right? You solve it by simply multiplying AA to AB and then AA to BA. And then the same thing for BB to AB and BB to BA. So the answer, if you do it, it will be this AA, AB, AA, BA, BB, AB, and BB, BA. So this is the answer for 2, 3. The same thing you can do for 3, 2. So here is for 5, 5, 4. Here is for 4, 5, 5. Okay, so it will be AB, BA, and AA or BB. So the answer will be AB, AA, ABB. So the answer for 1, it will be basically this 2 chunk, right? This 2 chunk of statement or messages, right? And then if we go up one more level for node 0, it's basically 415, 415. So for 4, is A, for 5 is B. So that means if you put it here, okay, bit running out of space, but you put it here, A should go in front of this guy and B should go behind, right? So that means you would get A, B, B. A will go in front of everybody, B will go behind everybody. And then A, B, A, B, and then A, B, B. All right. So let's look at the answer, whether it's the same. Okay, just comparing the answer. It looks the same. So we are able to solve this part. Right? And then the second part will be very easy. It's basically just to match basically whatever that you have come up with, the messages, with whatever that is given and give it the count, the intersection. Right. So before we get down to coding, we need to think a bit about our recursive function. Like how we're going to structure it. What are the conditions and what is the base condition, right? So first off, we need to translate the example or the input to a tree. So this to me looks exactly like a map, right? You have a key here and then you have a value here. So it's a key value pair. So key 0 is 1, has value 1, 5. Key 1 has this values. So then we look over at the map part, right? So once you this map contains the key value pair. So whenever you have a key, you need to get the value. That means you need to be able to handle a key as well as the values. And then there are two types of values. We mentioned that there is the n value pairs or n value group, and there is the all value group, right? And not to forget, there is also a base condition of A or B, which is 4 or 5 in this case. So it needs to be able to handle a key. So a few scenarios, it needs to be able to handle a key, which is just 1 digit. It needs to be able to handle a value. So there are two types of value. So there is the n group value, the all group value, and then lastly, there is the base case. It needs to be able to handle the A or B. So the base case is easy. When you have A or B, you just return A or B, right? The key is okay as well. Basically, if you have a key, just return the value, right? The more difficult part is the what happens when there's an n group or all group. So for all group, right? For all group, you need to be able to loop through each of the key and pass that and recurse that. And then when the result comes back, you need to be able to end it. And here is another function which we will look at it later. Okay, so that's what n should do. So for each of this, it needs to be able to recurse on the key. For OR, basically, it is almost the same. It's just that it is not, the result is not finished. So you need to be able to probably use an array, right, to pass just the left part of it as well as the right part of it, the left branch and the right branch, and recurse it. So that is roughly the plan, right, for our function. So let's look at the code. So first off, we have the input, right? So that is not much to look at. Basically, you just read from the file, and then there is the main guide, which is the recurse function. Okay, so here I split them up into two input files. So basically, the first one is just the map itself. The second one is the message. This is the second part that we have to match the messages. But first, we have to get all the values first. I mean, we have to get all the messages first from the map. So the good thing about using Elixir is that you have, if you have terminal, you should have the IEX. So interactive repo will allow you to run any function in the terminal. So you can test your code very easily. So first off, let me just import my module. I just name my module. And then let me import the map. So this is a map from our example. Next, there is the recurse function. So this is the meat of the program. First off, there is the base condition. The base condition is just if the value is A or B, just return A or B, right? And then there's a condition of if it's a key, if it's just one digit, then you just recurse it based on the key. Sorry, the value. I mean, you pass on the value. All right. So what's remaining is if it is a or if it's an and. If it's a or, you just recurse by passing on the left tree, which is the left side of the value, or the right tree, which is the right side of the value. So if it's one, you just pass. If it's an or, so you just split it. You have the left tree and right tree, and then you pass on 2, 3 as the left tree, and then right tree will be 3, 2. Okay. So what about the and? So if it's an and condition, let's say if it's 2, 3, right? You need to be able to split it. So you split 2, 3, you split into 2, and then for each of this 2 and 3, right? So you have 2, 3 in the nodes, and then you need to be able to reduce it and combine them together at the end. So this part will actually do the reduction. Okay, so first we want to find out what about 2. So 2, we will recurse it again, because unless it's A or B, then we still have to recurse it. So we recurse it, but we put in a temporary array here so that we can accumulate it, we can combine it together at the end. So now the problem comes, like, what if I get the result of 2 and 3? How do I combine them together? So I have a method called permute list here. So we can look at how it works. So basically, permute list is the AND function, and given 2 lists, it will return the whole permutation range. So how it works should be very simple. Basically, here, if you give it list 1 is this, and then list 2 is this, when it combines and return, it will give you this. Okay, so we can try it out. Permute list. So if I just copy it, so you see this is the answer. Okay, so let's try to run the function on some very simple node, so we can see what it is doing. There's a trick here. All right. So for 2, first it will go here, and then the node will be 4, 4, and then 4, 4 it will go here, and then it will start to accumulate, right? So the first time, because it's empty, so it will just um, become just accumulated because there's nothing to permutate basically. Only when there is not empty, then you start to permutate. But basically, AA, you permutate it, it will become AA. And then 5 will become BB, and then you get the result for the OR here, which is AA in one list and BB in another list. Okay, so now if we try 1, okay, 1 is a bit more complicated. You get 2, 3, and 2, 3, and then so basically what you do is you will go to the left side of the branch all the way down, and then start from the right all the way up again. Okay, so for 1, we know that on the left side is 2, 3, and then you try to process 2, and then 2 will be 4, 4, and then 4, 4 basically 4, 4, 5, 5, it will just AABB. We saw this earlier. And then after that, you go to the right branch. The right branch will be 3. There will be 4, 5, and then it will be AB, and then 5, 4, because 3 is 4, 5, 5, 4. You go to the right side, and then it will become AA, BB, AB, BA. And then this whole thing, you will need to join together again because it's 2, 3, right? So it become this. And then the right side is basically the same thing, and then it will become this. So it's exactly what I've demoed when I drew it out, right? And then when you combine together, it becomes this. Okay. So this is 1. All right. So since it works like this way, if we do 0, basically what you do, it will combine A and B. A in the front, B at the back. So you get this whole chunk of it. Sorry, you get this whole chunk. So that is how the recursive function works. Once you got this down, the rest are quite easy. Basically, you just try to intersect it with the message and see what is the count. So that is what the main function is doing. So if I do main, so there will be 2 here. So that is the example. It's 2. So this is the example. So again, I do the same thing. We split it into 2 lists. One is the map and one is the message. And then I need to change the program a bit. And then so it takes a bit of time to run. And then the answer is 250. Okay, so that is part 1. So part 2, it wants to replace 8, node 8 and node 11 with these 2 new values. And then we can see that the value will actually repeat itself. So it's going to loop forever if we use our recursive function again, right? So we cannot just use the function and try to generate a bunch of messages and then try to match them. That would not work in this case. And they give us a hint. You only need to handle the rules you have. That means only the rules and the message we have that needs to be checked. So we have to approach it from the message point of view. So for example, in this example, they give us this, I think it's 15 messages, and then only 12 of them match. So we only check this 15 messages. That's it. let's go back to our drawing paper, and then we can see what actually this rules actually means. Like, what is the extent that we need to check our message. So first off is the 8. So 8 is made of 42 or 42 8, right? And then let's try to expand it. So this is the first iteration. What about second iteration? Second iteration will be 42, 42, 42, or 8. How about the third iteration will be 42, 42, 42 inside, and then it's 42 or 8. We begin to see a pattern because 8 itself is repetitive, so we don't actually need to care like you know, the position of 8. It's just going to repeat. So this part is just going to repeat, right? So immediately we can see that it's just 42 or 42, 42, and then all 42, 42, 42, or forever. Okay, so if you want to summarize this thing, it's basically 42 to the power of n, whereby each of them is a combination, right? It's a permutation, right? So where n is more or equal to 1. So that's it. Like that is the 8, the note, the 8 note. What about the 11? So 11, so 11 would be 42, 31. This is a bit tricky because it's in the middle. It's in the middle of 42 and 31. All right. So just change the color. Right. So next iteration will be 42, 31, 42. So this guy is in the middle. Okay, just change it so it's easier to see. In the middle, 42, 31, or 42, 11, 31. Right? And then there's 31 here. Okay, if we expand it out, it will be 42, 31, 42, 42, 31, 31, right? This part is 31, 31, and then 42, 42, 11, 31, 31, right? So we can see that or this is or here, you can imagine that this part will just keep on growing like a tree, right? So let's expand one more layer. So 42, 31, 42, 42, 31, and there are two 31 here. So the crucial part is the part behind, just to make it easier to see. So it should be 42, 42, 42, triple 31, right? And then you have 4 here, right? And then you have the middle part here, and then you have 4 here. So you can immediately see that the formula, if you want to conclude for this, it will be 42 to the power n, 31 to the power n, where n is more than or equal to 1. 0 is actually 8, 11, right? So you have you have something like, so 8 is 42 to the power m, this guy is 42 to the power n, 31 to the power n, where m can be larger or equal to 1 and n can be larger or equal to 1. All right, so you have like this if you want to make a conclusion, this will be your conclusion. This will be the conclusion. Okay, so now how do we limit the extent of this recursion so we can match our message? So for that, let's look back at the example. So I've taken the example and I split them into two files, right? And then I replace this guy 8, 42, 42, 8, and 11 with the corresponding. So we realize that from the message, we need to go through the message first, right? So again, back to our formula, this guy, that means there are limitation to how many repetition some patterns can be, right? So just add another page. So for example, if you have some message like this, right? It turns out that 42 and 31 from this whole map can only generate 5 characters combinations. So actually I've generated it, and this is from the example. You can do the same. Basically, you just need to recurse 42. So we can try to do that. Let's try to do that. There it is. So this is the map, right? So if you recurse just 42, just 42, and then you get this bunch of stuff, and then just 31, you get this bunch of stuff. So from our node, we see that the least you could have is 42, 42, the part of 42, and then another part of 42, and then the third part will be 31, because when you m is 1 and n is 1, that means the least you could have is this. I'm just going to do it like that. This, and then this. This is the least you could have. So you have 3 parts, right? And then the combination of 42 is all this, and the combination of 31 is all this. That means if the message that you get, right, is anywhere, if it has 3 parts, and then the first 2 parts are made of 42, that means anything from here, this bunch, and then the last part is made of 31, that means anything inside this bunch, it is a valid message, right? So for example, this guy has a length of 15, and then it's valid because it is made out of the message from inside here. So for example, if we can split it into 5, BBABB is actually something from 42, BBABB, see? And then BBAB is also from 42, BBAB, and AABA is from 43. It's not from 42. What is it? AABBA. This one, right? So they're mutually exclusive. And then if it satisfies this condition, that means the message is valid. So what we want to do is we want to split the message into chunks, and then we want to match it against the parts. But of course, the message has different length. So the longest length here is 45. That means it's made of 9 parts. So how many repetition of 42 parts and or 31 parts, right? We need to make out, we need to list them out, and we need to make out the list, right? So what happens if m is 1 and n is 2? So if m is 1 and n is 2, you have 231 behind. So you got 42, 42, 42, 31, 31. So this is valid, right? This is valid for a 5-part message. Of course, you can also have 42, 42, 42, 42, and 31, right? You gotta have 131 because n is minimum 1. So this is also a valid 5 parts message. So you have 2 permutations for 5 parts message. How about 6 part message? 6 part message, there is only one way, which is to have 42 5 times here, 5 times here, and then 1 time 31 behind, because you could not have you can imagine if n is 3, you're gonna have a 7-part message. So it seems like it only affects odd number. I mean, for multiple 31 behind. Other than that, it seems like it's mostly just 42 in front and 131 behind. So we need to pay attention to the ones whereby it has multiple 31 behind. So it turns out that well, for 7-part message, you can have 331 behind, all right. For 9-part message, you can have 431 behind. For here, and then there's another 42, so this 9. So this is the same for 8, and this is the same for 6, right? So other than that, everything in front is just going to be 42. So for 3-part and 4-part, 3-part and 4-part, which is the minimum, you have 131 behind, 131. For 5 parts, you could have 1 to 231 behind, 5 and 6 for 5 and 6 part. For 7-part, you could have 1 to 2 to 3 parts behind. For 9, you could have 1 to 4 parts behind. Like all those are valid, right? So if I just list them down, just so you don't confuse, this is just for 31 behind, because in front it's just going to be 42. So the only variation is the 31 behind, like how many parts. So for 3 and 4, it's only 1 part. For 5, 6 is 1 part and 2 part. For 7 and 8,
it's 1 part, 2 part, and 3 part. And then for 9, it's 1 part, 2 part, 3 part, and 4 part. Right?
Of course, we can go on until 11, 13, you know, things like that. We see the pattern here. So in terms of code, once we understand that, is very straightforward. So to understand what is this doing, we can just take an example. It's actually quite straightforward. For example, this guy, right? We can split the string for this guy, and you will see that this part should match 31. Should match the part 31, and this 2 parts should match 42. So this is the head and this is the tail. That's what I try to call it. And then if you have a longer list, for example, this is 13, which is a 6 list, so it should have 2 parts, right? So these 2 are the possibilities. So it can have 1 part behind, which is the tail, which is 31, or it can have 2 parts for 31. So either one of this match means this list matches. So we can go for an even longer one. The longest one is the one with 9 parts. So this should have 4 possibilities. Right, 1, 2, 3, 4. So the 4th one is whereby if you have 4 parts behind, any part of this can be 31. So if any one of this is a match, that means the string is indeed a valid message. So here, yeah, it's just the splitting. And then after that, we actually check the splitting. So we just check the subset, whether it is part of the subset. And then both parts have to be true. Both the head and the tail, the part 44, 42, and the part 31 have to be true, right? So either one of the part, so for example, for this long string, either one of the part, if it's true, the result will be true. So it will check for the entire message list, right? And then you count it. So that's it. That's the function. If you do part 2, this is just for example, is 12. Okay, we can do for the final example.
So it's 42, 8. Let's replace it and let's do it.
All right. Let's see whether it works. So one thing to take note is that the parts, the 42 parts and the 31 parts for the puzzle input is not size of 5. It's actually size of 8. Okay, you can check it out by just doing this. And then just try to run this. So we see that it's size of 1, 2, 3, 4, 5, 6, 7, 5, 8. So here we have to chunk it to 8. And then if we run it, it should show us the answer, which is 359. And bingo, that is the answer. So this concludes part 2, and this concludes the puzzle. Thank you.